Hello students. Hello, am I audible for both the divisions?
Yes, ma'am.
Yes, ma'am.
Okay, okay. From B division, because I have created separate links, that's why I'm asking. Okay, okay, thank you students. From B division, anybody? Just tell me whether my voice is audible or not. Okay, thank you. Just listen one thing. I have created separate links for both the divisions. So if anybody found that whether my voice or my video screen is not visible to all, at that time please interrupt me, okay? Because I am on the different screens. Okay, so within 2 minutes we will okay, within 2 minutes we will start our lecture. Okay, let remaining students also join over here, then we will start it. Meanwhile I will share my screen, so remaining student also can join in that time. Okay. Just I want to share one thing with you, because today you feel that uh, you are unable to join for the lectures. Yes, am I right? Yes. Many of students you feel like that we are unable to join over here. Within 2 or 3 days that issue will be get solved, because range of Google Meet is having some problem. That's why today you face such a problem. So within 2 days or 3 days, it will be get solved. Okay. Meanwhile, we will share different links for both the divisions, so you can join and you can attend lectures very easily. Okay. Just check why screen is visible to all for both the divisions A and B.
Yes, ma'am.
Okay. Thank you. Yes, from B division. Okay. All of you got your roll numbers? Updated list. Voter list updated at morning. Whether all of you got it?
Yes, ma'am.
Okay. So now we will move towards our syllabus. Okay. Before starting syllabus and introductory part, just I will give you introduction of myself. My name is Nimisha Deval. I have completed my BE and ME from the same college. And from last 2.5 years, I am teaching over here as assistant professor. I have currently conducted Java programming for third year. Actually, I have conducted for 2 times, and now also for talk also. This is second time, and before that, DMS I have conducted, as well as C# programming. Okay, so for this year, uh, pattern for your exam is get changed due to COVID-19, right? So simultaneously means whenever I will teach you the theory part of talk, means theory of computation, after completion of theory part, we will directly move towards its example simultaneously. Okay, so no need to take a separate session on tutorial. When we complete some part of your syllabus, simultaneously we will start writing or solving some examples. Okay, so you will not have a more gap in between theory as well as means problems. Okay. uh, okay, now remaining students are also get joined. Now I will move towards the first introductory part. Okay, and before moving toward introductory part, we have to see we have to see the vision mission statement. Okay, in morning session you have already seen. Just I will give you a little bit information about our vision and mission. This is the institute vision and this is our departmental vision. Same is for institute mission and department mission. Okay, whether you have taken this? Yes, students, whether you have taken this? If you have already taken, then we can move towards the next part, that is the syllabus, because you are also most interested in our syllabus, right? Yes. Okay, so this is our institute vision, institute mission, and department vision and department mission. Then program educational outcomes. Before that, objectives is there. Okay, objectives is means whatever you are learning throughout your academic part, that is from first year to final year, that will be covered in the program educational objectives. Meaning of your degree is nothing but the these three or four statements. And program specific outcomes means what? After completion of engineering, what is the actual use of your degree, means whatever you have learned throughout this 4 year, that will be comes under this part. Okay, so for your information, we have kept these statements in front of you. Okay, why you are learning and what is the use of all these learning methods in the future after completion of your engineering degree. Okay, these are the program outcomes. Okay, just I will highlight you main points, that is first engineering knowledge, then problem analysis, design and development of solution, conduct investigation of complex problems, modern tool usage, the engineer and society, environment and sustainability, ethics, individual and teamwork, communication, then project management and finance, and last one is the lifelong learning. These are the 12 main program outcomes. Okay, I will share this copy with you after completion of our lecture. Okay, so these are the some basic things that I want to share over here. Okay, okay, so now I will move towards your syllabus, actual syllabus. Uh, whether my voice is clear to all?
Yes, ma'am.
Okay, okay, thank you. Now, first I will introduce you the subject theory of computation. Okay, before starting our syllabus, I want to just share with you whatever you have learned in DMS. Okay, these are the basic points for our this subject. Okay, in DMS you have learned different types of sets, then different algebraic equations, algebraic theory part, as well as the groups, subgroups, monoids, like. Okay, you have already learned all those parts in the DMS. Whenever we will require such a things for designing the theory of computation, means part of a machine. Okay, we need some basic parts of DMS. Okay, just I will give you a simple introduction of theory of computation. Okay, whenever you are logging to something, means suppose you want to log into our Gmail accounts, you need to provide a password over there, right? You need to provide password over there, and whenever you are creating the password, at that time you have fill or you have written some text word as well as some special characters as well as some digits. Okay, so making the combination of characters, alphabets, that is alphabets and characters, digits, and after that some special symbols. With the help of this you have created the with the help of this you have created your password, right? Am I clear? Yes. Okay, so for designing such a type of a password, we need some programming. We need some programming, and that programming comes under this part. That is the theory of computation. Means we need to provide some pattern we need to provide some pattern while designing the password field. Okay, so this is the very simple example of theory of computation. Okay, now see, in syllabus already they have given you some introduction. Theory of computation lays a strong foundation for a lot of abstract areas of computer science. Talk teaches you about the elementary ways in which a computer can be made to think. Okay, and whatever we are designing logic for this theory of computation, that will be input for the computer in the 0 1 bit format. Okay, that part is a different part. We are learning only how to design such a logic. Okay, this comes in the next year, that is the system programming and compiler construction. That's two subjects are in your third year syllabus. Okay, in first sem of third year, system programming, and second sem of third year, compiler construction. Okay, so this is the sequence of your syllabus. In first sem you have learned DMS, now talk. In third year first sem SP, and third year second sem CC. So this is the sequence. So whatever you are learning from these subjects, that will be applicable for next semester. Okay, so be focused on your syllabus. Whenever I am teaching you something, try to practice it. Okay, because here no need to use any type of programming technique. Only you have to follow some rules, and according to rules you have to solve such a examples. Okay, then any algorithm can be expressed in the form of finite state machine. Okay, these words are new for you. What is mean by finite state machine? What is mean by expression? We will see one by one when we will start our chapters. Okay, and it can be served as a really helpful visual representation of the same. Okay, sometimes the finite state machine, the short form of finite state machine is the FSM. Okay, just remember, whenever I will call FSM, at that time it's nothing but the finite state machines. Machine is nothing, not like you are seeing the machinery part. Okay, this is not such a case. This is the visual representation of our finite states. Okay, representation of a finite state, and togetherly that diagram is called as the machine. Okay, otherwise you will feel like that this is like a machinery part. Okay, this is not a machinery part. This is the logical representation of finite states, and that together diagram is called as the machine. Okay, and that will be given as a input to computers. For that, providing computers as a input, we need system programming and compiler construction. Okay, then this FSM are easier to understand, thus helping cause furthermore. Okay, here prerequisite already given, that is the DMS. Okay, so main objective of this subject is what? To introduce you the computational principles to build regular expressions for given regular language. Okay, in today's lecture we will see what is meant by regular language and what is meant by regular expression. If possible we will take its example, otherwise we will take it in the tomorrow's lecture. We are having lecture tomorrow at 1 p.m. So whatever part we have remained today, that we will cover in the next lecture. Then second objective is what? To introduce different types of automata. So this is nothing but one by one different chapters. Okay, then regular and non-regular languages, context-free languages, and different types of push-down automata and Turing machines. Okay, so these are the different chapters in our syllabus, and its main aim is what? To build a regular expression for a given language, design different types of automata, then classify languages into regular and non-regular languages, then detect ambiguity in the grammar and convert into unambiguous grammar and normal forms. Okay, don't worry about these words because these words are new for you. Whenever you will learn it in the lectures, then it will be very easy for you. Okay, last one is the design push down automata and Turing machine for a given language. Okay, so regular expression is the first chapter of our syllabus. Okay, in that these many points are the expression corresponding regular language, examples, applications, union intersection complement. Okay, the union intersection you have already learned in the algebraic system. Okay, only some changes in the definitions, like only changes in the definitions, such as symbols. Okay. Then second chapter is the finite automata. According to structure means actual syllabus of theory of computation, means globally structure, finite automata is the base for regular expression. But according to our university, regular expression is given as a first chapter. So don't worry about that. Simultaneously we will see it. Okay, because both are dependent on each other. Third chapter is the Clean's theorem. When you will learn these two chapter, then this will be very easy part. Okay. Then fourth chapter is the grammar and languages. Like our English or Marathi grammar, here also you need to use the grammars to solve examples. Okay. Then second section, push down automata, context free grammar. In that, context free languages, non context free languages, CFL. Okay. Turing machine and variations of Turing machine. Variations is nothing but the types of a Turing machine. Just you have to understand it. Okay. Any queries? Still, we have not started any point. Just I have given you introduction about it. Okay. Are you comfortable in English?
Yes, ma'am.
Or you?
Yes,
Okay.
ma'am.
Okay. So should I continue in the same language?
Yeah, ma'am.
Okay. Thank you. Now I will move towards the syllabus, and in that first chapter. Okay. Already notes are there, so I will directly open it. But for example, I will solve over here. Just for theory part, I am using scan notes. 1 minute. Just check whether visible or not. Is it visible?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. So this is the first point of our syllabus. Regular expression and its corresponding regular language. Okay. So first we will see what is mean by regular languages. Okay. What is mean by regular languages. Okay. First I will mention the theoretical part of regular language. Then I will give you some examples so you can understand it very easily. Okay, first, regular languages are languages. 1 minute, I will highlight over there. Regular languages are languages that can be generated from one element languages by applying certain standard operations in a finite number of times. This is the theoretical part definition. Okay, when you apply this part in our day-to-day life, then how it will work? Okay, just I will give you one example. The string, whether uh, let it be. Okay, just consider one string ends with ing. Okay, just consider a string ends with ing. In that part, you can write one sentence as mention the words in the English language which ends with ing. Okay, what statement I have made? Mention the words which ends with ing from the English language. Okay, that statement is nothing but the regular language. Okay, that statement is nothing but the regular language. I am giving you day-to-day life examples so you can understand it very easily. Okay, then in same fashion you can write the words ends with ed. The words ends with ed. That is nothing but the statement, and that statement is nothing but regular language. Okay, this is not an actual example of theory of computation, but for your understanding I am giving you, because whatever statements I am using over here, that you have to write in the regular expression format. Understanding what I'm mentioning over here. Right now I have mentioned the words in the English language that ends with ing, and another statement the words in the English language that ends with ed. Okay, so this is nothing but the regular language. Now understood this meaning? Regular language are languages that can be generated from one element languages. Okay, that characters means ending with ing. This is nothing but the bunch of characters or set of characters. Okay, that comes in the format of one element languages. Means each word or each character from this string act as a one element and by applying certain standard operations. Now, you are mentioning that the words ends with ing. Ing is nothing but the combination of three characters, right? Ing is the combination of three characters, and that three characters are concatenated with each other. Means one operation is applied on that ing, and that nothing but the concatenation. Means by applying certain standard operations. Okay, now understood the definition? Okay, just I will repeat it once again so you can understand its example at the time of practice. Regular languages are languages that can be generated from one element language by applying certain standard operations a finite number of times. Okay, finite number of times means you need to use the concatenation operation for multiple times, means finite number of times. Okay, so different words are there which ends with ing. You can see here only that is the corresponding, right? Then helping is there. Then yes, from your side. Okay. uh, from tomorrow's lecture join in a time, okay, because what happened, I am using two screens at a time, so I am unable to understand from which division you are joining, because right now we are using the different links for both the divisions. Okay, so join it within a time that will be very easy for both of us. Okay, so this is the definition of regular language. Okay, then they are the languages. Now I'm moving towards next part, that is the characteristics related part. They are the languages that can be recognized by finite automata. Okay, now I will tell you. Regular expression and regular language can be represented in the diagrammatically format, and that diagrammatical format is nothing but the finite automata. This is our second chapter. Okay, diagrammatic representation of regular expression is the finite automata. Now I will give you the sequence. Regular expression is generated with the help of a regular languages, and finite automata is generated with the help of regular expression. Okay, and vice versa. If you have provided finite automata, then you should able to write the its regular expression and regular language. Okay, so these are the sequences: regular language, regular expression, and finite automata, or finite automata, regular expression, regular language. Okay, this simple operation includes concatenation, union, and clean closure. Now, this clean closure is new for you, but you know concatenation as well as union. Right now, for ing, I have shown you one thing. Okay, then by the use of this operation, the regular language can be represented by explicit formula. Okay, that formula is nothing but the regular expression. That formula is nothing but the regular expression. Okay, so next was nothing but the regular expression. It can be thought of as the algebraic description of a regular language. Okay, I will give you one information, like you are making the addition of two numbers. Yes, any queries? Yes, students,
No,
any
ma'am.
queries? Okay, here some cloudy nature is there, that's why you will have different noises from my side. So let it be for today. If you feel like that my voice is not clear, then please disturb me. Okay. Okay, now I will move towards the regular expression. Before starting regular expression, I will give you one example that there is a one expression that is addition of two numbers. Okay, addition of two numbers. That addition of two numbers is the language, regular language. At whenever you are mentioning the two numbers, in that case, what you are doing, you are mentioning the numbers. Just see, I will give you here. Just a second. Okay. See here. First, I will give you regular language. For regular language, you can use the short form RL, and for regular expression, you can use the short form RE. Okay. So, regular language is addition. This is not an actual example. I am giving you some part of this so you can understand it very easily. Addition of two numbers. Okay, this is a regular language, and whenever you want to convert it into regular expression, in that case you have to mention only two numbers, number 1 plus number 2. This structure is nothing but the regular language, sorry, regular expression. Okay, whenever you are writing in the format of a statement is nothing but the regular language, and whenever you are mentioning it the format of some symbolically format or alphabetically format with the help of a digits like this comes under the regular expression. Okay, but whatever you are writing in the regular language, that must be reflected in the regular expression and vice versa. Okay, don't take tension, because whenever you will practice it, that will becomes automatically in your logic part. Okay, so this is very simple example. Now you have to follow some rules while designing regular expression. What are these rules? These are the three, and this one is the four. Okay, so total four rules you have to follow. So first rule is what? Every letter of the alphabet, that is the set. We are mentioning set with the help of a summation symbol. Every letter of the alphabet is a regular expression. Okay, means whatever A to Z alphabets are there. It may be small, it may be capital, uppercase or lowercase. What is one characters are there from A to Z letter, small and capital, are nothing but the regular expressions. Okay, if you write a simple A as a regular expression. Okay, if you have written simple A, it also considered as a one regular expression. Okay, if you have written ABC, this is also called as a regular expression, and its regular language is nothing but the regular expression having a word ABC. Okay, having a word ABC and C. If this is the ABC, means this is a complete word, and if you have written it as A plus B plus C. Okay, just see two things. I have mentioned here one as a ABC, and another one I have written here as a small ABC. A plus B plus C. Its meaning is what? It togetherly comes in front of us. That is complete ABC as a word. And here it will come as a split part. Here plus operation act as a OR. Plus operation act as a OR. Means either A will be there, or B will be there, or C will be there. Okay, so its regular language become as the word having either A or B or C. Simple statement. The characters in the word having either A or B or C. Okay, so this is the difference in between these two statements. Okay, just understand it. This is not actual examples, just I am giving you all the rules before starting the examples. Okay, so just remember over here. I have already mentioned in the part of rules, but for your understanding purpose, I have mentioning over here. Any queries in first rule? Yes, any queries in the first rule? Every letter of the alphabet comes under a set as a regular expression. Okay, shall we move towards next example? Okay, okay. Whether my speed is too fast?
No, ma'am.
Yes, students. Okay, no problem related to speed. Okay, whenever you will feel like that my speed is too fast, at that time mention me. Okay, so I can reduce my speed. Then, then second rule for regular expression, null string. You can mention the null string with the help of a epsilon. Okay, with the help of epsilon or this symbol. Okay, this symbol is also called as the null string, and empty string with phi. There is a difference between null string and empty string. Okay, there is a difference between null string and empty string, because null string is acts as a one. Okay, uh, now see, null string and empty set are the two different things. Whenever in the set, whenever in this set, this string is mentioned either in the format of epsilon or this letter. Okay, this will be considered as a one element. Okay, just I will show you over here. Okay, I will drop this part just, and I will mention here one regular expression add. Okay, what a statement is there? Suppose they have given you a set of string containing a null value. Okay, please listen. Regular language statement clear for you. Okay, I will write here this statement. Write a set of strings, set of string containing. Now we are moving towards our examples. Okay, write a set of strings containing null values. Okay, so whenever they will provide you the regular language, in that case you have to first write the set for it. Okay, what a regular language they have provided you, that you have to convert it into first into set, and then you have to write its expression. Then you have to write its expression. Now see, what is the statement? Write a set of strings containing null values. It means in this set, either you have to mention the epsilon character. Okay, either you have to write epsilon character. Okay, or you have to mention the this one. Meaning of both the statements is one and the same. Okay, meaning of both the statements is one and the same. It means in this set there is a one element that is the null string. This is also called as the null string. Both this epsilon and this one is the null string. Means it contains some value. Okay, and its regular expression is nothing but the its regular expression is nothing but the only epsilon. Okay, because one element is there and that element is nothing but the epsilon, or you can write it as a like this. Means set of string containing null values. Null values means nothing but the epsilon or this one. And whenever empty string is there, here you can see empty set. Empty set is nothing but nothing will be present in that set. Means completely empty. Okay. So for empty string, I will just keep same part over here so you can understand it, and simultaneously you can see right set of empty string. Already you have seen in the DMS, but for revision purpose, because you cannot understand it otherwise. Okay, now write a set of empty string. Empty string is nothing but nothing will be there, and its regular expression is nothing but the phi. Okay, its regular expression is nothing but the phi. Okay, any queries in it? So take a screenshot of it. For example purpose, I have given you over there. Okay, empty string, its regular expression is the phi, and its set does not contain anything as a element. Okay, so take a screenshot, or you can write, if you want to note down it, you can note down it. Okay, because these are the very basic things. If I have written in the rule format, then you will not understand it. That's why I'm given here some examples. Clear? Okay, now should I move towards next point?
Yes, ma'am.
Okay, so third rule is what? We have covered two rules. What is the set? And null set, empty string. Okay, third rule is what? If R1 and R2 two regular expressions are there, and for languages L1 and L2, means R1 is the regular expression for L1 regular language, and R2 is the regular expression for L2 regular language. Then first option, R1 comma R2. Just see, I am not giving a description, just see one by one. First is R1 and R2 separately. Then these two are different regular expression. R1 is the one and R2 is the another. Then second one, what is the second option? If you have written R1 R2 concatenately, then it will be concatenation of R1 and R2. Now suppose R1 is the group of digits. Okay, uh, 1 minute, I will give you example. That will be very easy. Okay, so RL1, set of set of digits. Okay, means in the uh, in its set, what will be there? 0 to 9 numbers are there. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then RL2 is this set of first five, or you can take it as a some characters. Okay, I will take here from A2. Okay, so in this set, what will be there? Only 5 characters are there: A, B, C, D, and E. Okay, you can take a whole set, but it will take so much time. So I have taken only 5 characters. Okay, so these are the two sets. And what is mean by R1? Sorry, regular expression 1. Regular expression 1 is nothing but set of all digits from 0 to 9. So whenever they will provide you set of digits, in that case your regular expression become as in bracket 0 to 9. Okay, this is the regular expression for regular language, that is the set of digits. Okay, I am giving one step over here to you. Okay, this is one step against your syllabus point. Okay, that is the what a regular language is there, and its regular expression is represented as like this. Okay, set of digits is nothing but like this, and set of alphabets from A to E. In that case, what will be there? In that case, what will be there? A to E. So you know the sequence, so you can mention it as A to E, or by comma, by making comma also you can write over here. Okay, by making comma. So to avoid comma, you can write here as A, just a minute, B, C, D or E. This one is the one option to mention the regular expression, or A to E. This one is also allowed. So both the regular expressions are allowed over here. Okay, but whenever you are mentioning the complete set of alphabets, means capital A to capital Z, small a to small z, in that case don't write in this fashion. Okay, here limitation is fixed, means only 5 characters are there, so we can able to write this, but there is a sequence of all characters. In that case you cannot like this. Okay, so just mention in the format of this way. Okay, this is applicable for 4 to 5 characters, maximum 6 to 7. Okay, but whenever you will consider complete set of alphabet, then mention in the format of like this, means small a to small z, capital A to capital Z. Okay, so just I have given you 2 examples. Now we will move towards our rule. R1 and R2 means here R1 and R2 means regular expression 1 and regular expression 2. Okay, these are the two regular expression. Then R1 R2 means concatenation of R1 and R2. Concatenation of R1 and R2. Then third one is R1 plus R2 means union of both. Union of both. R1 star and R2 star, clean closure of R1 and R2 are also regular expressions. In same fashion, positive closure is also there, but we will see later. These are the 3 basic rules applicable for regular expression. Okay, now we will see one by one. First we will see concatenation, then union and clean closure. Okay, then first R1 and R2. Here R1 R2 is nothing but regular expression 1, regular expression 2 is nothing but what? Combination of both. Combination of both the sets. How we can make a combination of it? First you need to design a set and then you have to write its expression. But right now we will not write its expression, just to mention that how it works. Means if you have taken 2 separate regular expressions and if you have making its concatenation, then that concatenation part is also act as a regular expression. Okay, so its combination is work as 0 with A, because first all elements from the set 1 and then second element is from set 2, means 0 with A. So 0A is the one element, then 0B, 0C, one minute, comma is there, 0C, then 0D, 0E. Okay. Okay, next part from your side, can you just tell me what will be the next string? Okay, just 1 minute. This will act as a one string from your set. Okay, combination of this one, whatever we are making over here, that will be act as a one string from a regular expression. Okay, now tell me what will be the second string after completion of this part?
1A,
Yes,
1B,
student?
1C.
1A.
Correct. Okay, and this will be continued up to 9A
1E.
to 9E. Okay, so this complete set is also act as a one regular expression. And how to mention it in the format of regular expression? Means here you have to write 0 to 9 set followed by A to E set. Okay, so this one is the regular expression. That's why this one is also one regular expression. That's why we are making as a rule R1, R2 also act as a regular expression. Okay, means we have done the concatenation. Same is applicable for 1 minute. Okay, same is applicable for union. And whenever you are making the union, in that case, what will happen? You have to check the sequence, whatever it may be. R1 is there first, R2 is there. Okay, can you just give me what is the union of these two strings? Means a set of first and set of second. Okay, just I will mention here. Yes, can you tell me? Yes, just think. Union of both. What will be set of strings over here? Yes, students. Any guesses? Is my voice is audible?
0 to 9
Yes, ma'am.
plus 8 to E.
Correct. Okay. So whatever strings are available in both these sets, that will comes under this parts, means 0, comma 1, comma. Whenever you want to skip some part, but that part is available over there, in that case you can mention here as a dot, comma 9, comma A, B up to E. Okay, so this is nothing but the union, and this union is also act as a one regular expression. Okay, then third one is what? Clean closure. Okay, before moving towards its actual example, just understand one meaning, what is meant by clean closure and what is meant by positive closure. This is the part of a closures. Clean closure is nothing but the zero or more occurrences of a string. Okay, zero or more occurrences of a string. Okay, if you have written, should I rub this so I can show you this example? Or if you want to take a screenshot, you can. Taken?
Yes, ma'am.
Okay. So I will rub this one. I will mention here as regular expression 1 and its clean closure. Clean closure is mentioned with the help of a star. Okay. Clean closure is mentioned with the help of a star, and positive closure is mentioned with the help of a plus operator at the as a upper string. Okay. Let it be. I will mention here. Otherwise, you will follow the same sequence. Okay, here also same is applicable, but if I have written like this, then you will not able to see it. Okay, now first first set is what? This one, set of digits. Okay, and whenever you will find out set of digits as a regular language, and you have to write its clean closure for regular expression. Okay, okay, just leave both the things. I will take another example. Okay, see, just I am writing here regular language. What is the regular language? See here. Set of all strings, set of all strings of 0 including null. Okay, this is the one statement. This is the one regular language. Set of all strings of 0 including null. Or this statement can be written as, okay, this statement can be written as set of all strings of 0 having 0 or more occurrences for the set. Okay. If you will confuse, then I will write here 1. That will be very easy. Okay, set of all strings of 1 including null. And second statement is what? Set of all strings of 1 having 0 or more occurrences for the same. Okay, or 0 or more occurrences, that will be also sufficient. So I am giving you here ideas how they can write these statements. Okay, so meaning of this is what? Okay, uh, just I will write here its regular language in the format of set, including null. Including null is nothing but epsilon is there. Okay, epsilon is there, or you can write this null also. I will mention here as a epsilon comma. Including 1 means single 1 is there, double 1 is there, triple 1 is there, 4 times 1 will be there, and it's going on. Because this infinity part, we don't know when it will stop, because they have not mentioned the length of our string. Okay, so it will be get continued. Then whatever we have written here, that will be clean closure. Means clean closure is nothing but the 0 or more occurrences of our string. I will give here space so you can see it very easily. Okay, 0. Whenever we are mentioning the 0 occurrence is nothing but the null value. Means how it works? 1 raised to 0. Okay, just I will mention here 1 raised to 0. 1 raised to 0 is nothing but the 1 minute. Okay, we will see only this part and then we will stop here, because right now 4 7 is there. So we will see this rule, and fourth rule we will see in the next lecture. Okay, just 1 minute. 1 raised to 0 is nothing but the null value. Okay, anything raised to 0 is nothing but the null. Okay, whenever we are writing in the format of a algebraic, means in the mathematical convention, at that time we are mentioning it as a 1, right? But here anything raised to 0 is called as the null. Then next one is that 1 raised to 1 raised to 1. We can mention it like this also. 1 raised to 1 is nothing but the single string. Okay, then 1 raised to 2 is nothing but the 2 times 1. 2 occurrences of a 1. Again, 1 raised to 3 is nothing but the 3 times of a 1. Understood this part? Okay. Any queries inside it? Next string is? Yes, what is the next string?
One
Yes,
raised to four.
students?
1
Okay,
raised to 4
correct.
times 1.
Right.
Yes, ma'am.
Yes, correct. All of you given a correct answer. 4 times 1. So all these strings comes under the clean closure of your regular language. And how you can write it? What is the regular expression for this statement? 1 star. Okay, whenever you are mentioning the star is nothing but the clean closure. 0 or more occurrences of given string. 0 or more occurrences of given string means for this one means 1. Okay, and whenever we will see in the next lectures how you can write for multiple strings also, what is the regular expression. Okay, and here clean closure. 1 minute. 1 minute, I will give here so you can see it easily. Okay. Second one is what? Positive closure. There is a single difference in between clean closure and positive closure. When you see clean closure, 0 or more occurrences of a given string, and positive closure is nothing but 1 or more occurrences of a given string. Means this part, we will exclude the empty string from our set of strings. We will exclude the empty string from our set of strings. Then it will be called as a zero, sorry, positive closure. That is the one or more occurrences of our string. And zero or more occurrences nothing but the clean closure. This is the simple definition of clean closure and positive closure. And clean closure is a big set. Positive closure comes under this one. Okay, so its property become as clean closure is the set of clean closure is nothing but the set of null value plus positive closure. Okay, so I will write in the format of a, okay, so whenever I will give you such a things, just do one thing, write somewhere in your notebook. Okay, because these are the one very basic rules that will become for MCQ. This is one part of a MCQ. Clean closure is nothing but the combination of null means empty string, sorry, empty string mean uh, null value, that is the epsilon, null string plus complete positive closure, and this union is nothing but the clean closure. So this is the one rule that will come for 1 or 2 marks in your example, as a example in your exam. Okay, so this is the rule, as clean closure is nothing but the union of null string plus positive closure. Okay, just remember, clean closure is nothing but zero or more occurrences of a given string, and positive closure is nothing but one or more occurrences of a given string. So we have seen different MCQs in today's lecture. Okay, for each line there will be a chances of a MCQ. Okay, and last rule is nothing but if a string can be derived from the rules, whatever we have seen first three rules, is also called as the regular expression. Means with the help of above three rules we can design the regular expressions. Okay, understood? Set of alphabets, null or empty string, and empty set, and these three rules: concatenation, union, clean closure. Okay, any queries? No queries? Okay, how many of you have given the attendance? Okay, so today mention your roll numbers in the chat box for both the divisions. Mention your roll numbers in the chat box. But from next lecture, I will conduct your attendance. Okay, one by one. Yes, yes. Those who have given attendance, they can leave. Have you understood? Yes, students. Whatever we have seen today, have you understood it?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. So whenever you will feel like that you have not understood, then you can discuss in the lecture only, or you can give me a part whatever you have not understood, so we can simultaneously discuss over here. Okay. Actually, talk is very easy. If you have learned from basic, then it will be very easy for you. Okay. Anybody else who has not given the attendance?
Hello, ma'am.
Yes.
Ma'am, can you share the notes so we can note down?
Yes, yes, no issues. I can share. Whether should I share?
Okay, ma'am.
Hello, am I audible?
Yes,
Hello.
ma'am.
Okay. Should I share after completion of lecture or meanwhile? Okay, whenever we will complete our chapter simultaneously, I will share whatever PPTs or whatever PDF files are there as a notes after completion of our lecture. Okay, because
Yes, ma'am.
when we will complete the complete chapter, then it will be very easy for you. So at the end of chapter, I will share with you. Otherwise, you will get confused. That's why. Yes, from B division, anybody else who has not given the attendance? All of you given the attendance? Okay, so thank you all of you and take care.